hope the cat doesn't wild out.
Okay, hey everybody, welcome back. This is another live coding live stream. Earlier this week on Monday, we were doing some Rosetta code problem solving, and we hit upon a problem that involved finding humble numbers, which we'll talk about in a second. And we figured it might be a good idea to create an actual function that tests whether a number is humble, which again, we'll talk about later, and try to submit this to what is called the Wolfram function repository, which is a way that anyone using Wolfram technology can access functions that have been written, submitted, and approved and use those in their own code. So it's a great way to expand the whole Wolfram resources, and pretty much anyone can do this if you have the skills. So once again, I'm joined here by Zach. If you want to introduce yourself again.
Hello, I'm back again. I'm very excited. We're gonna hopefully make a submission to the Wolfram Language repository, and we're also gonna learn a bit more about it. So excited.
Yeah,
We're, al-
and we
we're also
also have
joined.
with
Go ahead.
us today someone from the Wolfram Function Repository team. So we're very excited to have him here, and that's Bob.
Hey, it's great to be here.
All right, with that, let's just dive right in. I'm going to start sharing my screen here. All right, so a small recap. We have over here the Rosetta code problem that we were solving on Monday, and this was about finding humble numbers, which are positive integers with no prime factors greater than 7. And over here is just a notebook of the solutions that we came up with live with all of you there. If you're interested, that's in the description of the YouTube link from Monday. So anyone can go ahead and view that notebook if they want. And let's just talk about humble numbers a little bit more. So we're looking and making sure that it doesn't have a prime factor greater than 7. And it turns out that humble numbers are actually a specific case of a more general thing called smooth numbers. So for example, an n smooth number has no prime factors greater than n. So we wanted to make a function that tests whether an integer is smooth with respect to some prime number. So maybe we'll call it smooth integer q or something like that.
Yeah, and so a 7 smooth number is what we solved as a humble number.
Exactly. On Monday, we were solving for 7 smooth, aka humble numbers. Yep. And the way that we were testing for them at that time was by factoring some integer. This is just some integer. And then this is the way that you can get its largest prime factor. It's the last and then the first. And so this whole thing here is the greatest prime factor of some number. And then we were testing whether it's less than or equal to 7. We might try some different methods. This factor integer is pretty robust, but for very large integers, especially ones that have a lot of different prime factors, it can get pretty complicated for the program to actually find all those factors. So we're going to explore maybe some other ways that we can actually go ahead and find whether it's smooth or not. So I'm going to create a new blank notebook just so that we can start writing the function. Eventually, we'll switch over to the function repository notebook itself. But for now, we're just going to try to write out the function. And the first question then is, what do you call it? I say probably smooth integer q makes sense. Does that sound good to everyone?
I think it makes sense.
Yeah.
Although we could call it n smooth integer q, since it
Okay.
does depend on, some number n.
Now, the only issue that I might have with that is if n comes first, it would be capitalized because all
Yeah,
function names are in caps.
Okay. See,
And then it
yeah.
looks like numeric
can't
smooth
be that.
integer to me.
Yeah.
Yeah. Yeah, I would say this would probably work. We'll give it a shot.
All
So
right.
it's going to be some function. So it's got some square brackets where we'll put the inputs, and then it'll have delayed assignment to some value. So what its inputs are going to be the number that you're testing, whether it's smooth or not. I'll just call that num for now.
Do we
And
wanna define that as an integer?
Yeah, so it has to be an integer input, otherwise it doesn't make sense to ask. Doesn't make sense to ask if a real number is in as a smooth number, right? What are the prime factors of 5.6?
Mhm.
So the way that we can do that is with pattern checking. This little underscore means it's some pattern that has one element, and this means that it has head integer, which is an atom, if you know what that means in the Wolfram language. Um, Little things like a or one, those are atomic.
So, so if we,
Hmm.
so if you try to test this function right now and you type in, 1.1,
Right.
is it gonna, it's gonna throw back and say you didn't enter the pattern correctly, and it's not even gonna,
It would return unevaluated because we haven't defined a definition for this for things other than integers.
okay, I understand.
Yeah,
And
so we've
and
defined,
for numeric functions like this, that's
right?
good. Imagine that you just had x for an undefined x, and then at a later time, you
You,
could substitute, you could set x to an integer and it would evaluate.
Oh, yeah, that's
Right.
a good point.
So returning unevaluated for numeric things like this in a symbolic programming language is a powerful tool.
Yeah,
Right.
exactly.
okay,
So we have a bare bones function here that just returns the input, but
very
exactly
cool.
like Bob just said, if we pass something that wasn't an integer, then it returns just the function of x. But then when we replace x with, say, 7, then it actually returns 7 instead of some error or something like that. Yeah, so that's the
Okay,
advantage.
I see.
And okay, so good. We've got
Does
a
smoothness readily apply to negative integers?
that is a great question, and I think we'll get more into it later.
Great.
But yeah, is there a good way that we could restrict this to just positive integer? I know that if we did this, it wouldn't work because that's not a head. Um, is
Would
that
it
what you were
just,
thinking, Bob? Something like that?
Yeah, I mean, you could have a pattern test. You could add the question mark after integer, and then you could say
Yeah,
like greater than 0. But
right.
but I don't know if you would want it to return unevaluated for the negative case. You might just want to have an if statement in the definition and give a failure or false immediately.
Right. It looks like there's a good question that Bob might be able to answer in the chat. Does anyone know what other languages had built-in pattern matching before Mathematica? I'm gonna guess there wasn't any.
Oh, I don't know. I'm not a good historian
Yeah, that's a good
of
Steven
languages.
question. Hmm.
Yeah, maybe Lisp. I don't know. People have thrown around that as sort of something that predates Mathematica and had some similar concepts.
Hmm. And I would imagine symbolic manipulation program probably did as well, which was Steven's first
Oh, sure,
program.
right, yeah,
Hmm.
yeah.
But that's kind of cheating. Okay, so we've got something that takes an integer, and we also want it to take the number that you're testing smoothness against, right? So if you're testing 7 smooth, this would be where you would put 7. And this has to be a prime number. So we need some sort of way to check that the input is prime. I'm going to call the prime number, let's just call it P. That's the name of the variable that we'll take in.
yeah. For now, we can also make that pattern match that to integer too, since it should be
True.
an integer. Well, we can probably do a check in the function itself, but
Yeah, so there's two ways that we could do this. Like you said, we could just have this be an integer and then check whether P is prime and return an error if it's not prime. Or we could have this only be a pattern that applies to prime numbers. And a way that we could do that, this looks a little complicated here, but this is a pattern which tests whether it's prime or not, and it's named P. So when reading things like this, it helps to start with where the underscore, the pattern is,
mhm.
and then look to the right and say, okay, it has to be prime. Look to the left and say, okay, it's named P.
So this would also unevaluate if we gave it, not a prime, right?
Yeah. So for
Theoretically.
example, right now the function will just return num and P if it if it evaluates. So if we said 5 and something that's not prime, like 6, it returns unevaluated. If we say something that is prime, like 7,
Okay.
then it returns that.
Okay.
Bob, what do you think is better, to have it check that it's a prime before it evaluates, or to throw an error if it's not a prime?
Well, what do you want to do when it's not prime?
Right.
I think is the question. Do you want to give a message and a failure? Seems,
Maybe.
or do you want to return unevaluated? If you want to return unevaluated, then you certainly want to do it just as you have now.
Right. Would that look bad though if someone tried to put in 6 or something and returns unevaluated, and they'd say, geez, the function doesn't work or something?
Yeah, I think that would. I think I would probably leave it like this, and I would add a second definition that's looking for integer, that just underscore integer, and then I would have that issue a message and wording. Well, I would have two definitions, right?
Oh, okay.
Right. If I was trying to write robust code.
I see. So we would have
And then
this.
if somebody put in something that wasn't an integer at all, we would
Right.
fall back to that symbolic case where it returns unevaluated.
Okay. Yeah, I see. So you're saying this could be something like, we have some definition up here for P being prime, and
Right.
then we have some definition for an integer where it throws
And
an
that's
error.
just going to give an error.
Yeah.
And a message, either failure with the message in it, or
Right.
or message with and then dollar failed or something. Right.
Yeah, we'll put something.
There are a few different idioms for failures in Wolfram language. But yeah.
Yeah, is it robust enough to just say failed there?
Oh, it's definitely nicer to give a message.
Yeah.
And sort of the more modern approach is to give a failure object that contains the message.
Okay, we'll get into that in a little bit.
Sure.
First, let's try to actually write this function. So the way that we had written it before was we factored the integer, and then we took its largest factor, and we compared whether that largest factor, was greater than or equal to some prime number. We were using 7 before. So this is pretty simple to read, because it's going to say, okay, it's true whether the largest prime factor is less than or equal to P, and it's false if it's greater. Nice. We can work with this for now, especially because we're pretty confident that it works. So for example, let's see. We have 7 should be 7 smooth, right? Good. So should 14. But for example, 11 wouldn't be 7 smooth because its highest prime factor is 11. Yeah, that makes sense. Okay, so it's probably working the way we expected. If we did something like putting in 2, obviously that's still false, and 4 should be true, whereas 3 would be false. Okay, good.
There's just a couple messages in chat.
Yeah.
Dennison pointed out, he said that it's very good that we are not leaving things unevaluated, we're returning a failure. And if we were considering to make a contribution to the Wolfram function repository, that is definitely something you should always do. It's always better to be verbose. Nothing's worse than not understanding why your code's not compiling. So
Right.
definitely doing that is a good thing. There was also a couple other things. People were wondering if a prime or a smooth integer could be a negative. There's actually a Math World page about smooth numbers, and it seems to be that a smooth number is a random positive integer. A random negative integer can't be smooth because I guess it's not a product of the positive prime numbers. So that's kind of what we're going off of. Well, obviously we're not experts in number theory,
Right.
but we're going to follow the resources we have and do our best with that. But continue.
Prime number.
I guess, well, I guess it has a prime. I guess it does have the rest of it, just the first one is -1.
Right. It depends on if you think of -1 as prime, which obviously no one ever does.
It's a convention whether you want to include negatives or not.
Right.
Hi, Danny.
It might make sense to include them because this idea can be extended also to Gaussian integers.
Okay.
Yeah.
So we should include negatives, you're thinking?
Um, I I think it's up to you, but if there's a thought of ever extending this function to Gaussian integers, then you definitely should.
Okay.
If you want to restrict it simply to integers, then it's up to you.
And it would function such that if, let's see, if the absolute value of an integer is smooth, then its negative value would also be smooth, right?
Yeah, yeah.
Okay.
For regular integers, that would be the criterion. For Gaussians, it would be more complicated, of course. But yeah.
Yeah. Also, yeah, for everyone watching online, we just had Danny tune in. You want to introduce yourself?
Probably work better if I take myself off mute again. Yeah, hi, Daniel Lakeblau. I'm with the Wolfram function repository team, among other things, at Wolfram, and wanted to step in and see how this is going. Looks like
Yeah.
it's going quite well.
Yeah, thank you. We're very excited to have a great team here helping us out.
A user did have a question about the difference between p:\, underscore prime q as opposed to having no underscore.
Right. Okay, so the second one, the one that we used, so this is what the question was about, the difference between these two. This is the one that we used. This one doesn't actually mean maybe the same thing as this, in that, so I think the confusion comes from things like this, where this is saying some pattern named num, which has head integer, and head is different than a test. So this prime q isn't a head, it's a test of whether a number is a prime or not. Integer doesn't test whether a number is a prime or not. It is an integer, like 7 has head integer, it's atomic. And so what's going on here is it's saying this is a pattern which fits the condition that it's a prime, and we're naming it P. I think the colon can be a little bit confusing too. If I turn to the documentation here and we look up colon, we see that there's 3 different meanings for it, all with a slightly different definition. The one that's going on in the way that we were using it is pattern. So it's some name of a pattern and then the pattern object itself. So it's matching something to a prime q. Oops, this guy's matching something to a prime q and it's named P. So that we
In
can
this case,
refer
though,
to
they
it later.
would both work the same.
Oh, this one would work the
Yes.
same too?
Yeah, they're both
Yeah.
work
Oh,
the
okay.
same. Yeah.
All right. Yeah.
Very cool.
When the test is applied to the entire object, you can omit the colon, and it'll be the same.
Oh, I see.
You would need the colon if the test if the things to the right of the colon are more complicated, and then you're
Okay.
matching the whole thing. If you wanted to test part, like if it was a list with 2 parts and you wanted to apply one test to the first part and another test to the second part, then you're definitely going to need a colon.
Okay.
Okay.
I see. So this would work the same way. Yeah.
Well, there you
Cool.
go.
Then we'll leave it that way.
All right.
Great. So we've got one definition for the function here. We just, like we'd mentioned earlier, it can get very time consuming to find the factors of very large numbers. To demonstrate that, let's just grab some random integer that's pretty big. So maybe it's between 10 to the 50th and 10 to the 51st. So some really large integer.
Okay. All right. I'm
Range,
going
yeah.
really big.
I don't know, you think that's big enough? I got that.
Oh, okay. Well, never mind then.
It's going to get a percentage of those,
Yeah.
but
Some of them
it
are going to be
won't
much
get 'em
easier than
all.
others. Yeah.
Okay.
Because
If
like you can
you
see.
take say 10 random integers in that range, I'm guessing one will be a little bit time consuming to factor.
Yeah. Let's see. So we're going to map this across those.
Okay.
Yeah, one of them's
Yeah,
taking
if
up
you
a
do
lot of time.
timings, you'll find at least one. Well, I can tell you the first one was
difficult because it's
slow,
got two
and
big ones, right?
there's another one that has two big factors. I think it's the 6th or 7th,
Mm-hmm. So
and the
the more of those,
ninth.
it's harder, right? Or I guess
Yeah.
more time
So
consuming.
yeah, a few of those were on the slow side.
Yeah.
Okay.
Yeah. So that's just demonstrating that trying to find these really big prime factors can take a long time. As a lot of you might know, it's kind of an open challenge to always find the next prime number. And that's because they're really darn big.
Yeah.
And
That's not related to factor integer speed, though.
right.
It's yeah. Yeah, what's a challenge, like an RSA type of challenge, is to factor certain ever larger products of, say, 100, 200 digit number primes.
Right.
Not hard to validate a 200 digit number as being prime. Take two of them, multiply them, factoring that can be really slow. I don't
Okay.
know if it can be done with today's
Yeah.
technology.
Okay.
And so for those reasons, it might be better to stick to just the prime factors that we're interested in, right? Instead of trying to find all of those prime factors, why don't we just find how many primes of primes less than or equal to p show up in num? And one way that we can do that is by using a function called integer exponent. So what's going on with integer exponent is it's trying to find the highest power of the second input that goes into n. So if we put all of the primes less than or equal to p in there, it will tell us all of the exponents of those numbers. So for example, if we were to actually implement this, if we find the exponents of 4, oh, sorry, I have to put in a second input. So we'll do primes less than or equal to 7. So there's one factor of 2, 3 factors of 3, and that's it. Cool.
So what would it look like if this had a prime factor more than 7?
It wouldn't. So for example, if we did this times 11, right? This now has a prime factor greater than 7. We get the same output, 1, 3, 0, 0. And that might look like, oh, okay, those two look the same. But what we can do is try to reconstruct this number by exponentiating this guy with these exponents. So now we've got, okay, trying to reconstruct this number with just these prime factors, we get 2 and 27, 1 and 1. Multiplying those together, we only get the 54, we don't get the 11 back. So if we were to compare this to the original number, it wouldn't be true. And let's just actually return the 54. So I'm going to multiply all of those guys together. And now we have 54 instead of 54 times 11. So if we were to have some number in here and then compare this to that number itself, this is another way that we could test whether it's constructed only of primes 2, 3, 5, and 7.
Okay.
Yeah. Does that make sense to everyone?
That's a clever way of doing it.
For example, we can do this for the numbers up to 50, and we see that 11 was false, and some other ones were false. That actually wasn't as illuminating as I expected. But yeah, basically, this is another way that we can test whether a number is humble, has only prime factors less than or equal to 7. Now,
I just sent you some code from Danny. We can try this too. This should also be short.
Okay, so there's another way that we could define the function here too. And what's going on?
You don't have to use the n divided by, you could just use your that times whatever equals n would be just
yeah, so there's a difference between the ways that we wrote this where you're saying n divided by something equals 1. I just said this equals n.
Yeah, I actually think yours might be the slightly preferred.
The one reason why I actually like yours better is for the case where n is 0. And the reason I'm saying that is if I did my method and I say num is 0, this is what I wrote, yeah, it would say false. And I feel like it should be true. And the reason
I'm
for
not
explaining-
sure what it should do in that case. I think maybe we should. There may be a convention. I don't know.
Yeah. Right. And I
Yeah,
believe that
zero and
yours.
one are edgy edge cases.
Mhm.
One perhaps is smooth, regarded as smooth. Zero, I have no idea.
Right.
Math World defines positive integers, which is what two numbers come from, as numbers 1 and greater. So
Okay.
So maybe if n is
Because
1,
every
we
prime
should.
goes into 0, whereas that's not the case of 1. All the primes that divide 1 are small, that because it's an empty set.
Maybe we should throw an error if n is 0, or yeah, if n is 0.
Or we could define it as not smooth.
yeah,
Mm.
I would
That's
lean
true.
towards just false.
Just say
Yeah.
it's not smooth.
One thing I forgot about when we were discussing earlier whether to return on a value or not is that we're naming this thing Q, smooth integer Q.
Yeah.
The convention, if you have a function that ends in Q, it should pretty much always return true or false.
Yeah.
Okay.
Right.
So if that's a convention we can keep, we should.
Yeah, yeah. We're only doing true or false unless there's an improper input.
Okay.
Yeah, that being the case, I would define 0 as false.
It's false. Okay. Okay. Yeah, and it looks like both of our methods probably do that.
Okay. Let's test it.
Right. Yeah. Let's test it. So
If mine doesn't, you would just, restrict it to n greater than equal 1.
Mm-hmm. Yeah, so what is going on here is instead of having this list of 2, 3, 5, 7, which I wrote because I know that those are the primes less than or equal to 7, we're having the program itself actually create the list of primes less than or equal to p. And this way it's very general. Someone could put in the prime 11 and we would be using the list 2, 3, 5, 7, 11. And since it's used twice, it makes sense to use it in some with statements so that we don't have to redo this calculation twice. And besides that, I think this is pretty much what I wrote up to this optional argument here. So what this is saying is if there's only one input to this function, if you only put in an integer, then the p, the prime number, has a default value of 7. It'll use 7 if there's no option given. If you pass in another prime like 11, it would use 11. But this is just what it uses if you don't tell it a prime.
That was a lame effort to maintain humility.
Keep our numbers humble.
Alternatively, Brian on the live stream suggested having an operator form. So we'd have to think about what's more useful for the one argument. A default that becomes humility, or an operator where presumably the one argument would be p, and then you could apply the operator to, within data structures using something like query or data set.
Right. That's a really good point as well. So someone might prefer to have the single argument be, this is a question of whether a number is 7 smooth, as opposed to the way that we've defined it, this is a question of whether 6 is 7 smooth, which I think the way that we have it does kind of seem to make less sense than this being a question of whether a number that you would then pass to this in the form of some other input is 7 smooth or not.
So, all right. How would we write this in operator form then?
How would we write this in operator form?
Yeah, because
You would
Great
just
question.
do, yeah. Well,
we would need
you can go ahead.
to I might
rhetorical.
need some help with this. It was slightly rhetorical, not
You want
wholly
an up
rhetorical.
value, I think. I'm
What?
sorry.
I wouldn't do an up. Yeah, sub value.
Sub value.
Yeah.
What's
So
that?
you just keep going on the left hand side, and then you'd have an open bracket with an underscore integer.
Right.
Right. Just
Here?
where you were,
Uh-huh.
to the left of the colon equals.
Oh, okay.
You would just open bracket and underscore integer.
Oh, okay.
We'll give it a name. Yeah, give it a name like n.
Cool.
Instead of being redundant, repeating code, I would just put that back into the 2-argument form: smooth integer q and comma p.
Exactly like this.
Yep.
That makes sense. Great. So we have some function up here defined with 2 inputs. And then down here, we've defined the same name for the function, but with 1 input is defined as a call to the function that we just defined, but with p being some new operator and n being acted on by it. So that's pretty neat. And one thing that we could do is we've kind of claimed that this method with integer exponent is faster, more efficient than using factor integer. Do you guys want to go into whether that statement is true or not, or just kind of assume it is true? I think it's pretty fair to assume it's true, but I'll leave it up to you whether you want to start writing up the function repository documentation or explore some timing.
I don't know. I don't know if what would be is this radically slower? You think there'd be any process that would radically slow this down? Because I thought what slowed it before it was factor integering all possible, integers of every number we give it. But now we're significantly decreasing the amount of calculation we have to do. So
Well, why don't you take these 2 guys and name one of them smooth integer 1 and the other one smooth integer 2, and then just that same array of 10 large integers that you had before.
Right.
See, just compare absolute timing on.
Yeah, and something that we might want to consider too is if one is radically quicker than the other for small inputs too, right? That's important as well somewhat, because not everyone's going to be using some number with 50 digits. And smooth integer q will do 1. So this is the method. 1 is using factor integer.
You'll need to do a hash comma 7 or something, right?
Oh, yeah. Should we use 7?
We're using the 2-argument. Yeah, whatever you.
Yeah. That's a good point. Thank you. Yeah, we'll try it with 7. Yeah, that makes sense. So this will give us the timing of that. And we'll do it again with smooth integer q2. So this one is using integer. Whoa. So.
And take off the ones, make sure they give the same answer.
Oh, yeah. Yeah, good point.
It's good. Good testing during development.
Of course, yeah. Yeah, so that was 5.4 seconds versus 0.000. Yeah.
Yeah.
Okay, it looks like they're all false.
Yeah.
That makes sense. They
Not
all have
surprising.
Yeah, pretty large prime factors in there. Great. So this was evidently quicker, or at least those test cases. I'm going to try again with some slightly smaller numbers and see if the difference is as clear. Okay, that one's really quick now. And this one's actually taking longer time to do using integer exponents, which I somewhat expected that for smaller number inputs, it's going to take longer to use the integer exponents, but they're both still, extremely quick. So what do you say? Is it better to have a function that is really fast, or let's say fast for small and large inputs, or one that's really fast for small but slow for large inputs?
I mean, if we were putting this in the Wolfram Language proper, we'd probably take advantage of both cases and have some heuristic to determine. But
Oh,
if
But for our
we're
case,
trying to get something that doesn't necessarily need to be as smart as possible for the function repository, I would be doing 2.
all right. So we're going to stick with this definition. We can talk later about messages and errors for if P isn't prime. In fact, I'm just going to, I think we wanted to do this, right? Any reason not to? So do that. And let's start talking about the actual function repository. So the way that we can pull up a blank function repository submission, go to file. Well, this is on
There's a
Windows.
couple of tweaks I would make to the definition.
Oh, yeah, sure.
So because it's a queue function, we want it to always return true or false.
Right.
I would use triple equals instead of the double equals in there.
So that's testing for absolute sameness, right?
You'll never return an equation, right?
I see. Good point.
You're always going to return true or false. And I would consider having another definition, smooth integer queue, blank blank equals false.
Oh, okay. So smooth
As a
integer
catch-all.
queue.
so this
Yes.
is just if there's nothing put in, it'll just be false.
Yes.
Okay.
Yeah. I mean, I would probably put a comma in between them because the operator,
Oh,
if they put a non-prime in the operator, we probably don't want it to give false until they apply it. Yeah, I think that's right.
yeah. Does this
That's
make sense? 'Cause-
those are the 2 tweaks I had in mind.
Cool.
Well, now if they pass a non-prime, would it return false immediately?
I think so. I think that's probably what we want for a queue function. I don't know. What does Danny
'cause
think?
Yeah.
Question is whether it returns false immediately or throws an error message, probably.
Well, try removing that and then running it without a prime, and then try putting it back in and seeing what it does.
Yeah. One thing I'm just going to do is, since we have so many different definitions of smooth integer queue,
I think it would just return false if it wasn't prime, because it's got the other two won't evaluate if it's not prime.
Are we talking about the second argument?
Yeah.
Yeah.
I don't think it has to return false. You're basically, if you're saying giving a second argument of 6, you might be saying, well, all prime factors have to be less than 6 or equal to. So that would mean 2, 3, 5.
I guess that's true.
I don't think you have to restrict that second argument to be a prime. I think I did in the code I wrote, but I don't think it's necessary. Kind of, again, up to you guys how you want to make the convention.
Yeah.
Well, yeah. Let's test it and see if this will return true now. Ah, okay. So it does return true.
Right,
So
because
every
prime pi,
less than 6.
I
Okay.
think that's actually pretty nice.
Is this so? What does prime pi return? I guess
Prime pi is the number of primes that are less than or equal to p. Well, I'll pull up the documentation.
And prime pi accepts reals as well.
Oh yeah.
So you could even accept reals, which Sander had suggested we accept on the chat.
That's true. Yeah. Yeah, we had a suggestion. Why not have a 5.3 smooth number? And I suppose that would be just as good, because the only time p shows up is, like you said, inside of prime pi, which accepts reals, and prime pi then returns an integer, which goes into range and prime. So that would work just as fine. Yeah. Okay, cool.
Right. Probably has to be positive, right?
P.
Well, you definitely don't want it to be real. Then it wouldn't work on integers. So you could do a pattern test like question mark positive.
Oh yeah, because that won't work if that's negative. The number can be negative, but I don't think the p real can be negative, or because then you
No,
wouldn't
that
get
needs to be positive.
You're right. Yeah. So would that?
But I would you don't want that real. You don't want real because that will not take integers.
I see.
So you could just say, so you could apply like just p greater than 0. Would that be a pattern, or is positive already? Is positive Q?
Oh,
We're
you
just
could do
going
greater
for
than
it.
0, sure. Yeah,
Oh, okay.
you
I
could do
see.
that. But that, yeah, same thing.
Okay.
So this should do the same, right?
Let us
Let's see.
test.
So it works on integers, works on reals, and for a negative.
False. Well,
Oh,
there you
that's
go.
what we wanted from here, right?
Put
False.
put in -5 for the integer. No, for the
Or-
number, not
oh, yeah.
the prime.
Yeah, so
And
we're having it now where anything
and then put 5 in.
that's not a
Yeah.
number is returning false. Is that what we want? Or do we want it to return unevaluated?
For a Q function, I think you do. I think that is
Okay.
what you want.
Yeah, you
Okay.
don't want unevaluated for a Q function.
Okay.
Good. So let's use this definition unless there's any other suggestions.
I can't think of any.
Yeah. So let's try to start making a Wolfram function repository item. So we've got a new repository item, and there's one for function repository item, which is what
Why
we're
don't
going to be
we,
making today.
before we get into that, why don't we go over to the function repository and talk a little bit about it, just so
Yeah, good idea.
people weren't aware of what it is, we can kind of look at it.
Yeah, this is what the function repository is. It's one of our resources. And what we have is a lot of user submitted functions, and these all have to get approved, but so that means that they're all pretty well made. Just because we've got a really good team here, obviously Bob and Daniel, who are some of the people who would be looking at these functions. And for example, we can go into higher computational math. We've got a lot of functions here that people have made. We'll just look at one of them. So we've got some cool resource function, which I could copy. And if I go back to what I was using here before, I could use this resource function in my own desktop installation of Mathematica to do whatever I'm doing. I'm not really sure what K-NS graph is. It looks pretty, but there you have it. I don't have
That
to
looks cool.
import anything. I don't have to, I don't know, do anything crazy like that. I just pull it from the resource function. So that's pretty much what the function repository is. Anything else to add?
Oh, I can't think. I don't know if anyone else has anything to add, but we can get started writing it because
Yeah.
we are running a little short on time.
Okay, so this is a blank function repository notebook. And the first thing that goes on is you type in the name. So we were calling it smooth integer q. That's the name of the function. And we need one line explaining its basic purpose. So see, anything that we should compare it to?
Probably the documentation, right? I think we talked about this a little bit. If we look at maybe prime Q and the documentation, that might be a good one to base our definition.
These little description blurbs are
Mhm.
kind of unique to the function repository. The built-in documentation doesn't have anything exactly equivalent to that.
Right.
I like to think of it as sort of like the marketing tagline for your function, right?
Right.
When
So
people
maybe
are
we
doing
could
a
say
search,
something like,
yeah. And the grammar we use is usually we wouldn't say tests, we would say test.
yeah, you're right.
Right.
Yeah, so we're not describing what the function does, we're describing what you can use it to do, kind of. So test whether an integer is smooth with respect to another or with respect to a real.
A prime number? Or
Yeah, but we just said it doesn't have to be prime, right?
oh,
Well, but for the description, it doesn't hurt to be slightly more specific
Mhm.
to a maximum, a largest prime. I don't know,
Check whether the prime factors of an integer are
or a prime bound.
below a value, or below a threshold.
Okay, so test whether the prime factors of an integer are less than
A
less
given
than
threshold.
a given.
Could use that.
I like
Yeah.
that.
That looks neat.
We got no period at the end.
Yeah, no period at the end on this one. Just a one sentence blurb. This code that we'd written up. And basically you just copy paste that in there and you've got your function definition. I don't think we need to do anything else in the definition section. So we'll go on down to the documentation. Now this is more similar to the built-in documentation. So we've got the usage, which is this kind of blue section there. Details and options is similar to that. So what we want to do is be as true to the conventions of the Wolfram language as possible. And so we're creating something that's somewhat similar to some other Q function like prime Q. So what we want to say is smooth integer Q of, now there's two inputs for ours as opposed to prime Q, but we'll say maybe N and P.
Looks good.
And all of this should be templated, right?
Yep.
Yeah.
Yeah, so there's this neat little button template input that turns segments of typed out code into good looking format, basically. You see how the N there is italics, stuff like that.
It's
And
all built into the notebook too, so
yeah,
there's not a lot of like guesswork you have to do.
so this returns true if if there is no prime factor of N greater than P.
And then we need to format
All three
N,
things.
P, true and false.
Yep. So true is in the language, N is referring to that N, P is referring to that P, and false is in the language.
I think the usual wording is and false. Otherwise, I don't care too much.
Yep, that sounds good.
I do want to know why template input is working so fast for you when it never works that quickly for me.
I mean, we're just lucky.
Bob,
You
I
know,
have found-
you know who we can ask about that. All right. And this does end in a period.
Yeah.
Yes. Yep. So this is a full sentence, starting here and ending there.
Yeah.
Okay.
And we can just copy this cell. There's nothing special we have to do, right? I guess I'm
Yep.
just
That's fine.
Sure.
okay.
And
A lot
now
of
this is
times
an operator form.
Yeah.
A lot of
the
times in this
standard
case, we'll
wording
use
represents an operator.
represents,
form
yeah.
with integer Q that can be applied to a number or an
Yeah.
integer.
Danny's got it. That's pretty much the standard.
Is this what you said? Operator
Represents
form?
an operator form.
Ah, I see.
This is the Stephen developed wording.
And then that's all just represents an operator form?
A form of
Represents
smooth
an
integer
operator
Q.
form of smooth integer Q that can be applied to a number, say. I know it's more general. You can apply it to anything, but
Make sure you give integer a type for template input.
no.
Oh, it doesn't.
This is
I'm
referring
sorry,
to
smooth
just
integer Q, yes.
Right.
yes.
I thought
This is just the
Ah,
math
okay.
term
It's
integer.
no.
I see. Okay.
Yeah, smooth integer Q gets templated.
Yep, this one did.
Oh, it is.
This one does not. Yeah.
No.
Cool.
Okay, so I think we're pretty happy with the usage. For anyone who doesn't know all those conventions that we talked about, there's a helpful little information blurb here that can tell you a little bit, but one of the biggest hints is just to see the existing documentation pages and try to emulate the style that has been used for, well, decades.
It's okay. Details and options.
So we should probably, I'm just going to pull up, oops. I'm going to pull up the function definition alongside so that we can refer back to it. All right, what should we put in this section? We want to talk about its inputs, what it returns, what it means, right?
What it means to be a smooth, yeah.
Yeah. So let's say n smooth number is
Should
a
probably use P if we're using P.
That's a really good point.
Here.
Yeah.
Yeah, an integer is P smooth, is said to be P smooth if something like that. If its largest prime factor is less than or equal to P.
Yeah. Should I do fancy less than or equal to?
It's a matter of taste. I'd spell it out. Other people would do it the way you have it. I don't think we have strong rules on that.
Okay.
As
That
long
looks
as it's
good.
clear.
And these probably aren't templated, right?
The that one, I would, and the last one,
Yeah.
definitely. Yeah, I think I
Just so
would
they're
template
italic,
both.
pretty much. Yeah.
That's the
Okay.
sort of thing where if you're not sure, somebody in the review will figure it out.
Okay.
But I would go with template.
Okay.
Good.
And then what else do we want to include? We probably want to include to say like P can be not a integer. It'll
Sure.
just pick
Right.
the largest prime less than that number.
Sure, that's an excellent thing to put in details on options.
So P can be any positive real. Is that succinct?
Yeah. And it will, it'll pick the next prime less than it.
Right.
Yeah. You say, if P is an arbitrary positive value, the largest prime less than P will be used, or less equal to, I don't know. You have, yeah.
Yeah.
Yeah. Yeah, that's fine.
Good.
And then is there anything else we need to include in this? I can't think of anything.
Could we say, or does it make sense to say this function only returns true or false?
Or is that just
You don't have to. Our conventions with respect to Q functions are pretty strong in that regard, that nobody will be surprised if that it always does that.
I've always been curious. Do you know if Q stands for question, query, or just it's Q?
I've always assumed that it's one of those first
Yeah.
two, but I've not, after going on 30 odd years, I don't know.
Right. Okay. Yeah.
it means Q. That's
It
what
means
it
Q.
means. It means
Yeah.
Q. That's all I need.
All right. So let's get into the examples. Some basic examples. We should have just smooth integer Q acting on some number. Earlier we used 54, and we'll see if that's 7 smooth. And it is. So for this, could we just say 54 is 7 smooth?
Sure.
Yeah.
Yeah.
Or show that, if you like, show that too. Yeah, I mean, what you have is fine. Again, I'm just offering alternative
This is
wordings.
the example caption is certainly a place where the author can let their own style show.
Yeah, we do want it to be short.
Yeah,
but subject, essentially one sentence, but ending with a colon.
Yep. Yeah. So this is similar in style to code text cells, if anyone's ever written something using code text. But otherwise, yeah, it's exactly like it's done in the documentation there. Let's see. Do something that's not smooth. So we could do 54 again. That has factors of 2 and 3. So I guess it's not too smooth. Yeah, not too smooth.
Too smooth.
and then this brings up an interesting point about example delimiters. So you have to think: are these the same example, or are these two different examples? I mean, you're using 54 in both, so the second one does kind of follow from the first, but I still think that they're kind of distinct examples.
Okay.
Personally, I would put a delimiter between them.
I would have left it undelimited, but I can see, again, this is a case where I think if the author had a delimiter, we would not remove it.
Right.
Okay.
It's kind of up to the author whether these are.
In
what
this
do you
case,
think, author?
certainly.
Let's try it. Let's look at it with.
Oh,
okay. Yeah,
that's kind of nice.
I like that. That's fine.
Okay.
Yeah.
Scope. Is there anything we should include in scope?
Maybe certainly need to show the operator form. Yeah.
Oh, well, I guess that's fair.
A general rule of practice that I found is that every usage message in the usage above, in the documentation above, should be represented in the scope section.
So we can.
So you can either
properties and relations. You could, if you use the integer exponent definition, you could perhaps show that there's an equivalent factor integer definition, noting perhaps that it can be slow for large inputs. Under scope, that might also be a good place to say this operates on, the input need not be a small integer and just give some very large ones.
Yeah.
If you had made this listable with respect to either or both inputs, this would be the place to show it under scope. Not saying you have to or should do that, just if you had.
Yeah. The
might be out of time, but if not, the metadata is a good thing to show people.
Yeah, so just here I added a scope example. This is an operator which tests whether number 7 smooth, and then we use that operator to select the 7 smooth numbers less than 100.
We'll try to get through. We'll try to talk about everything as we go through. Go back to the someone brought up a really good point in the chat, just about including our Rosetta code solution in the applications.
Yeah.
Since that is that is an application.
Right. So we could rewrite what our eventual solution was. We were using some weird number generator, but yeah, if we rewrote that in terms of smooth integer Q, that would be a perfect, neat example. And
oh yeah, that would be good.
Or application.
Oh yeah.
Yeah.
Yeah. If even the less slick ones could be used under properties and relations if you wanted.
Okay.
Right.
And we could, and obviously we haven't finished writing entirely, but definitely just note down that we want to include that so that we remember, because we hope to submit this once we get it finished.
Yeah, let's take a minute to do this additional information section, and then I want to show the check button.
Okay, so created by, we would put probably here, we would probably just put something like Wolfram staff or something.
That's commonly used, yes.
But yeah, for anyone who's not us, you would just write your name.
You could write your name. It would be fine too.
Yes, that's correct.
Yeah.
Yeah. And wow. Keywords. So this one is functional areas, algorithm names. So it's kind of anything. I could probably say like smooth, right?
Yeah. Prime factors.
Smooth alone is probably not good. Smooth integers, humble integers.
Yeah, you definitely want to put humble in here. I mean, this is mostly useful in creating a search index so people can find it. So
right.
If somebody was looking for this function, what are they most likely to type into a search bar?
Yep. Yeah. So those are a few good ones. We might flesh that out later. Then we've got categories. There's a lot of these, but what these show up in is, there it is. These are all the categories so that people can say, oh, what's for fun? Here's a bunch of fun functions. There's a lot of them.
Fun is in the eye of the beholder.
True. It really is. Well, it's in the eye of the author, at least.
Yeah.
So I guess one would probably be the symbolic and numeric computation.
I would definitely go with higher math computation. I'm not sure I like symbolic and numeric.
Oh, okay.
Integer, it's returning a Boolean or integers. It's borderline.
Yeah.
And in a review meeting, if somebody thought that should be checked and it wasn't, they would say so, and vice versa.
We'll let the cat out of the bag a little bit. We're going to have subcategories soon, and number theory is going to be a subcategory underneath higher math.
Yep.
Oh,
so
cool.
You heard it here first, everybody.
and recreational math is going to be under just for fun. If you consider this humble numbers to be recreational math, you could check it. Again, author's choice.
I see. Okay.
Yeah, and there's no issue with checking two of these if it applies to both, for example, right?
Correct.
Check the just for fun, because we
check
did
as
have
many
fun
as apply.
making it.
Yeah.
This is definitely for fun.
We had a lot of fun.
Here you put related symbols, maybe prime Q.
So we should say that
definitely.
Related symbols is stuff from Wolfram documentation, not repositories.
I would also put integer exponent, I think, myself.
And factor integer. even though we didn't
Factoring,
use
yes.
it.
Yes.
It
Even though we
really
didn't use
isn't
it,
stuff that you used in the code. It's
things that are
it's
related.
the family of
Yeah.
the family of functions that
Right.
So it's
related.
kind of like
Factoring
this
is
seal. So
definitely
Right.
related.
Composite queue.
I find
maybe,
that this
don't
is
know.
extremely helpful for someone reading the documentation to say, especially with, okay, so there's prime pi, there's prime nu, there's prime omega. Which one am I looking for? You have no idea by the name, but
Mhm.
going in and seeing all the ones is helpful with that seal. So
None of those that you just named strike me as being related symbols, but what you have.
oh yeah. Mhm.
Definitely
mean,
add some more.
And then related resource objects. This is any Wolfram material that's been published by other people, right? So
Yeah.
Or yourself.
Something.
Or
Yeah,
yourself.
maybe something from the repository. I don't know.
We
if
have a whole
anything
bunch
out
of
there,
things
though.
about primes.
Yeah,
I
a
mean,
good
you
one,
could just search. You could just search prime in the function repository, and you'll find
math world
largest
probably
prime
help, right?
factor seems very
Yes.
very related.
Yes, that definitely.
Oh yeah,
That
largest
might
prime factor
be in the
is
reference. Would Math World go in the references?
No, that does not go in related resource objects. What you just did.
That
They should
goes
be
in,
names of resource functions.
links or citation, either or.
okay. So resources, not math world. That would be
Yeah, so
Right,
those
so-
are like
so
other
the-
functions in the WFR.
Also, demonstrations count as resources, I believe.
Yeah, you can
Yeah.
do them as data if there's something in the data repository. I don't know if we have a data resource that lists primes up to 10 million or something,
or
but
if
yeah,
it's,
you could imagine listing that.
or if
but
there's like a
yeah,
neural net.
Most
that's
of the
related.
time, exactly. Yes, neural
Yeah.
nets do. Most of the time, it's going to be other functions from the function repository.
I see. Okay.
So largest prime factor seems like the most important one to put there.
And links here, this is for non-Wolfram material. Right?
No, that's no. So I think what
It
you
could
put
be,
in source reference citation should probably be in links.
Okay.
Yeah.
And as two different cells. But
Yeah.
and yeah, source reference citation is more like if you've got the code from Emily's GitHub and she
Right.
wants
Or a journal
you to cite
paper.
her, right? Yeah.
Okay.
Yeah.
All right.
Yeah. Also, at some point you should run the check above. I think it
Yeah.
will tell you. I think it will give you some automated,
Yes.
including
this is really
changing
handy.
links.
This is the evangelism that I've wanted from the beginning of this meeting. Is before you hit the submit button, hit the check button.
I'm gonna full
Yeah.
screen this because it's important. So this found 9 suggestions. We've got some empty cells because we didn't fill in everything. So you would delete that if you were actually going to submit this. And we've got some helpful things like related links should be given as a labeled hyperlink. So
And what's really cool about this, go to on the little arrow on the right. You can
so
I
did that one manually.
Yeah, sure. And then say
this one-
convert to labeled
Convert,
hyperlink.
it does it.
This should do something kind of neat. Yeah,
Template?
see, so it goes to it grabs the title from the website and
very
formats it
Yeah.
according
These
to
checks
our
are very
URL.
important. It also goes
right.
to your bank account and writes us a check for the.
I see.
If only.
Yeah, but we have a bunch of automated fixes in there. So use that little arrow on the right of those warning stripes to fix all of your problems.
For links, it is impressively helpful.
Yeah.
That auto conversion, I have had great use from that myself.
Right.
And then another step to take that most people probably don't do before you submit to repository is deploy it to your own cloud account, and that will kind of create a web preview, and it'll kind of do two things for you. It'll show you how it's going to look on the web,
Right.
and you can grab your function from there and test it and make sure that it works as a resource function. The code here, there were no pitfalls. Occasionally you'll write code
message.
that has some part of it that doesn't really play well with the function repository and resource functions. Messages are a common pitfall because the symbol is no longer in the global context. The label of the message gets mangled, Or if you're trying to like create objects and pass them from one function to another function, and the object has some new name that you created, that's a common pitfall that'll probably fail when you try to make a resource function. There are a number of pitfalls, and the best way to catch them is to do this, create a real resource function, take it back to a new notebook, and test it.
I actually know for a fact that if you were to put some message in here and you were to check it, it would tell you, hey, don't use message, use the function repository version.
Resource function message.
Yes, resource function message.
The other thing to look for, sometimes under details and options, people need to use a bit of formatting to explain, math formatting. And sometimes the tools, the tool chain will not convert that very nicely. So if you deploy like this, you'll see.
If you have a bunch of traditional form math equations in details and options, which is great, you should do it. But some things are in a character set that is convenient for HTML and the web. So then you might want to, rasterize that cell, that expression, and use an image or something, or find a different way to represent your equation.
Yeah, so if I had some equation like x is real, that might not turn out well on the web, but I could probably rasterize this itself. We won't get into it now, but
there are certain things that may not, but the most important thing is when you're writing these to first check, make sure you pass the check, and then next deploy onto your personal cloud, and then try to pull it in another notebook or outside of this notebook with the resource function call. And then once you have all that, give it a once over and make sure, you cleaned everything up before you submit it to the team to be looked at.
Yeah, I think that just about does it, right?
I think so, unless there's anything anyone wants to wrap up with.
Yeah, we've got a really great, robust system here. Now, just because this is something that anyone can do and something that gets checked over really well, it still requires a lot of effort on the part of the author to actually go through and do all these things appropriately. So just make sure that we're not flooding this great team with a bunch of resources. Put your best foot forward, make sure that you've used the function before, that it works well, make sure you know what it does. That's kind of Stephen's 0th rule for writing, is make sure you know what you're writing about. So do that, write about it well, explain it well, follow all these guidelines, and just about anyone could expand the Wolfram resource system.
Okay. I guess before we wrap up the stream, we want to open it up to anyone in the next few minutes just to ask any questions they have about Wolfram Function Repository, any of the code we made. I noticed there was some talk about using up value, and we can maybe touch on that and maybe why we wouldn't use it for this, but anything else we can always answer. So take some time to ask questions, and if there's anything you guys want to tell us about the function repository or any exciting stuff coming up, we would love to hear it.
Any sneak peeks? Any more? Yeah, we also want to make sure to definitely thank Bob and Daniel for being here today. This was really helpful to have both of you.
It's our pleasure.
Quite welcome. Yeah.
When you're writing your test, because I don't actually know what the test section does. While you do, but be sure while we're doing this to ask any questions that you might have about writing a Wolfram function repository submission, or about the function repository, or just about the code that we used. But we'll finish writing this and then we'll wrap up. So
yeah, so question for Bob and Daniel that I have here. I know this says that tests can be input output cell pairs or symbolic verification test. Is there actually no preference, or do you prefer one over the other?
It does. I don't prefer one over the other. You can do more with verification. Like if you want to test that your function issues a message when it's supposed to issue a message, or that it finishes underneath a certain time threshold, or you want to add some sort of numerical tolerance, then you're going to need to use verification tests. If it's something like smooth integer Q with integer inputs, and it's super simple, and the output is a Boolean, then you can just put in a bunch as input output pairs, and we will basically process them into verification tests before we store them on the back end.
Oh, okay.
So it's easier to write them this way, it's straightforward, boom, boom, boom. But a lot of times more sophisticated tests require using verification tests.
Xander's going to submit a generate smooth numbers function.
Oh.
So we'll have something to test it with too.
Right.
Okay.
Well, okay. It doesn't seem like we have a lot of questions, at least for people that can answer it here. Thanks so much, Daniel, Bob, for coming. Thanks, Kevin, for coming. Thanks for anyone that watched. We hope to share this. We hope to do more exciting stuff like this. We're going to be live coding again next week, doing more Rosetta Code solutions on Monday, I believe.
Yeah. Yeah. After this live stream ends, you'll probably be redirected to the next live stream so that you can set a reminder for yourself and show up if you're interested.
Monday at 2 p.m. Central, and I think
Eastern,
that's
I believe.
it.
Or wait, are we
is
doing
it-
1 p.m. Eastern?
I can't
Yeah,
remember.
12 p.m.
Yes.
Central, noon Central.
Noon Central, 1 p.m.
All right.
Eastern. Okay.
Right.
And that's it.
Okay,
Oh,
great.
12.